sklearnutilsparallelbackend. Description: the parallel backend function in scikit-learn is a powerful tool for enabling parallel processing within estimators and other functions. It allows you to specify the backend for parallel computations, such as threading, multiprocessing, or a custom backend. This can significantly speed up operations by utilizing multiple CPU cores or even multiple machines. Inputs: backend. The backend to use for parallel computation. Common options include: threading utilizes multiple threads within a single process. Multiprocessing creates separate processes for parallel execution. Loki, a robust implementation of multiprocessing that handles object serialization more effectively. Custom backend. You can provide a custom backend object that conforms to the required interface. N jobs, the number of jobs to run in parallel. Specifying -1 will utilize all available cores. Prefer a string specifying the preferred backend. This provides a fallback mechanism if the specified backend is unavailable. Outputs: none. The function doesn't explicitly return a value. It modifies the global parallel backend settings, allowing subsequent scikit-learn operations to utilize parallelism. Steps: set the global parallel backend. The parallel backend function modifies the global settings for parallel execution in scikit-learn. Apply backend. It configures the chosen backend to handle parallel operations. Metrics: execution time. You can measure the time it takes for operations to complete. Comparing execution times with and without parallel processing to assess performance gains. Resource utilization: monitor CPU usage and memory consumption to understand the resource demands of parallel execution. Visualization plots: performance profile. Create a plot that compares execution times for different values of n jobs or different backends. Resource usage plot: visualize CPU and memory utilization over time to identify potential bottlenecks. Fine-tune parameters: n jobs. Adjust the number of jobs to optimize performance based on the available cause and pay nature of the task. Prefer experiment with different preferred backends to find the most suitable option for your system and task. Uncertainty methods: not applicable. This function doesn't involve uncertainty quantification. Challenges and fixes: challenge 1. Compatibility issues with custom functions. Sample use case that resulted in challenge 1 using a custom function that doesn't handle parallel execution properly, leading to errors or unexpected behavior. Fixes to challenge 1: ensure your custom function is designed to be thread safe or process safe. Depending on the chosen backend, use appropriate synchronization mechanisms. Locks, semaphores to manage shared resources. Challenge 2: communication overhead. Sample use case that resulted in challenge 2: high communication overhead between processes or threads for large datasets, potentially negating performance gains. Fixes to challenge 2: optimize data transfer and communication strategies, potentially by using shared memory or efficient serialization methods. Consider using a backend that minimizes communication overhead, such as Loki. Challenge 3: memory constraints. Sample use case that resulted in challenge 3: insufficient memory for creating multiple processes, especially when dealing with large datasets. Fixes to challenge 3: use a backend that manages memory efficiently, such as Loki, or adjust the n jobs parameter to limit the number of processes. Consider using techniques like out-of-core processing to handle large datasets that don't fit in memory.